So this is going to be our start of the part 2 of the Brick Breaker game. I'm going to skip over audio setup for right now. I'm going to go through the ball and the brick and the ball respawn portion. So let's start with our ball, and it's going to be an actor. So this is going to be a new blueprint class, BP. Oh, let me type BP ball. And I'm going to just make another blueprint class right away. It's going to be another actor. It's going to be the BP brick. So we'll start with our ball and brick. Later on, we will be creating other bricks, and that's going to make this more interesting as we add more bricks. So I'm going to go to the ball, and this is basically we just need we need a sphere, and off of that, I'm going to do the sphere collision. Again, the extent is going to be 50. So that you can see that it matches the ball. Again, we'll call this collision, and we'll call this model. And this is a standard that you'll see regularly that we'll call like the static mesh component, that is the visual component, the model, and then we can then do the collision is, it's named. Again, the idea is that we can swap in out the model as we see fit. Static mesh sphere, that's perfectly fine. This is where we're going to do our mirror M ball, and now it's our glorious yellow. We are going to add a projectile. I can spell it. There we go. Projectile movement. Our initial speed, we're going to set this to 5,000. Max speed of 25,000. The projectile, I'm going to bring this out. The projectile gravity scale, 0. So we're not going to use gravity at all. We are going to keep initial velocity in local space. Projectile bounces, should bounce is true. The bounciness, we're going to set this up to 1. Friction to 0, so that we're not worrying about it slowing down. Bouncy stop simulation, we're just going to set that to 0. And then there is a velocity. There we go. So the initial velocity we're going to set to 1.1. So we're not going just straight down the x-axis. We're going to go off by a little bit. We'll come back and we'll play with this initial velocity later on. But this is good to get us started. Actually, I'm going to go back. So before we go on, I'm actually going to grab the audio setup. I actually do need it. There's a zip file, and that's because, hey, so there are two sounds here right here in this credits forum. I'm basically going to go into my content draw. I am going to create a new folder called audio, and I'm going to bring these right into the audio folder. Come on. I'm going to, where did they go? There they are. There we go. So I brought in basically these two effects. This is pop, and this is going to be the boing sound. All right, compile. Now we do. Yeah, the one thing that we do want to do is right click and create a cue. This will be AC boing, and this will be hello AC pop. Now with the audio cue, we can go in and we actually can again we can press play, but we can go in and we can do things with it. Um, so here is the output. I know we can deal with the pitch. Here we go. So we can put a mod. So they've got a modulator node, and we're actually going to do this right for the Boeing right away. So it's going to go between 0.95 and 1.05 and a volume of 9 point. So it's going to modulate. So every time I play this, and I'm going to bring this to zero point 0.9 and 1.1 to so we can get go 0.85. Trying to get a And the whole point of doing this, like with this modulator, is so that we're not getting the same sound over and over and over again. So, um, the one other node I'm going to point out is attenuation, and that's basically if you're playing a sound that's supposed to be played within the world. The attenuation node is what's going to say this is a 3D sound as opposed to a 2D sound. Um, I'm going to. I'm gonna. I'm actually gonna plug in the attenuation. The heck of it. No, I'm 3,000 away. It's not gonna matter. For our purposes, I'm gonna keep it without. But if you were playing like an explosion sound, something again, it's supposed to be played in the world at a location. Again, in a more 3D styled game, that would be effective. You would want that. I'm actually going to just save that. We can close these. Let's go back to the ball. So let's go to its event graph. And we don't need any of these nodes. No, we do need begin play. Hello, why you not? Okay. So we're going to click on the collision, and it's going to be an event, collision. No, sorry, add event for collision. Begin. We want the. Is it? Yeah, we want add on component hit. Now, the ball bouncing around, we'll take care of that ourselves. So basically, what we're going to do here is the other actor. We're going to say get display name, and we're going to print that off. I'm going to use the append. So ball hit, and then we're going to play. In this case, going to be 2D, and this is going to be our boing sound. So we are going to create a function. So this is, again, I talked about this going above and beyond. Um, set random start velocity. And just go to our event graph on begin play. I'm going to grab the function and plug that in. All right. All right, so ultimately what we're doing is getting our projectile movement, and we're going to set the velocity of it. Let me see, grab projectile movement again. We do want to start with the get initial speed. Move this out of the way for one moment. We want to get a random float in range. And for our purposes, I'm going to say it's going to be negative 0.3 to 0.3. And we're going to make a vector. And this is going to be plugged into the y. We'll break the x. And we'll set that as 1. Not going to worry about normalizing it. I mean, I could, but I'm not going to worry too much about it being normalized. And then I'm just going to multiply this together. And that ultimately ends up being, switch this around, what the new velocity is going to be. We'll compile and save everything. And then we can go back into our game right now. Bring this, and I'm going to just drop I'm going to drop a ball into the map right away. We'll press play. You can see that it. I need to bring this up, and I need to take a look at the ball's collision. Generate overlap events, collision, simulate hits events. We do block all. Sorry, overlap all. Yeah, block all. Compile. We can go back in. What's going on? What's going on? So we advance a couple frames. Is it just going through? Shift F1. That's odd. Why is it not going through? Generate hits event. Um, Block all. Why is my ball going through the world? Let's go back to the ball. Collision, hit events, model. Let me grab the camera. And we're gonna, okay, get a better view of what's going on. So it is going straight through the wall. Why? Yeah, the ball has a collision. Watch this. Yes. Get rid of you. Component hit. Why is it just going through the wall? That's interesting. I will come back into that in 1 second, but I need to stop the recording right here.